and happy Wednesday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today, eventually, we're going to go on to section 6.2. But first of all, I had a request for some problems from 6.1. We'll start with those. One other thing, I don't know if I mentioned the Math Center hours yesterday. This is a Zoom ID. You can join it on Zoom. Anyway, here are the hours for that and the Zoom ID. Like I say, I don't remember if I mentioned that. Also, just a reminder, I don't use Canvas. The person in charge of Canvas has been telling me that people have been calling them, wanting to know where my stuff is on Canvas. It isn't on Canvas. Okay. Anyway, so here we go. We're going to take a look at some problems from section 6.1. This is number 4. Now, keep in mind that your problems might not be exactly the same as these. Everybody might have slightly different problems, but they're the same kinds. Problem number 4 says this. The terms x times x minus 1 and 3 times x minus 1 have a common, and then there's fill in the blank, factor of x minus 1. And the answer is binomial, because 2 terms is a binomial. I know the person that requested this didn't ask for that one, but I noticed they didn't have that one either, so I thought I'd do it. Anyway, moving on to number 6. It says, find the GCF of the list of numbers, and that is 80 and 96. So let's do the prime factorization of each number. 80 is 8 times 10. 8 is 2 times 4, and 10 is 2 times 5, and 4 is 2 times 2. So if I break it down, I have 2 times 2 times 2 times 2 times 5. Okay, so that's the prime factorization of 80. 96 is 2 times 48, which is 2 times 2 times 24, which is 2 times 2 times 2 times 12, which is 2 times 2 times 2 times 2 times 6, which is 2 times 2 times 2 times 2 times 2 times 3. Okay, so what's in common? Well, they both share a 2, they share a second 2, they share a third 2, they share a fourth 2. So the greatest common factor is 2 times 2 times 2 times 2, which is 16. Any questions about that? All right, let's take a look at number 18. It says factor the polynomial by factoring out the opposite of the greatest common factor. And what they mean is they want you to factor out a negative. Okay, so let's see here. Okay, so we're going to factor out a negative. Let's see, for 20, 30, and 30, the greatest common factor would be 10. So we're going to factor out a negative 10 and then a cubed. So what would be left behind would be 2a squared plus 3a minus 3. Now, that's the correct answer. The student that asked about this is what you had for your answer. If you'll notice, looking inside the parentheses, all of these coefficients are even, which means you could have taken out an additional 2. So that was the issue there. Okay, 27 coming up. Factor by grouping. 6t cubed plus 28 plus 24t plus 7t. The key to this problem is to put them in descending order by the variable before doing anything else. Now, there is no greatest common factor except for one. So we'll look for grouping. The first two, the greatest common factor is what? 6t squared. So we've got a t plus 4 left over. So over here, we have to have a t plus 4 because these have to match. And then we'll take out a plus 7, which gives me plus 7t plus 28. Then taking out the greatest common factor of both of those, and then the leftovers there. So there's your answer. Any questions on that one? Okay. Number 28, factor by grouping. Remember to factor out the GCF first. X cubed y squared minus 6x squared y squared plus 7xy squared minus 42y squared. Okay, I see that I can take a y squared out of everything. So I'm going to do that. Which gives me that. Okay. So now I'm going to go inside the parentheses and use factoring by grouping. The greatest common factor of the first two terms is x squared. And I have an x minus 6 left over. So over here, I have to have an x minus 6 if it's going to work, and a plus 7 outside. So there's my 7x minus 42. So now I have y squared times x minus 6 times x squared plus 7. Any questions on that one? All right. And finally, this is number 35, part B. It says factor, and we have 2x squared plus 2xy plus 2x plus 2y. Well, since there's 4 terms, I'm going to try grouping. Oh, but wait, there's a greatest common factor of a 2. So we'll take out a 2, x squared plus xy plus x plus y. Then we'll try to use grouping on what's inside the parentheses. The greatest common factor of the first 2 terms is x, with x plus y left over. So this has to have an x plus y left over and a plus 1 there. So I get 2 times x plus y times x plus 1. And there you have the request. Any other questions before we go on to section 6.2? If so, now is the time to speak.
Yes, where did the plus 1 come from?
Okay, so this, you wouldn't have to put it there. You could just put a plus sign, but you do need it down here. So basically 1 times x plus 1 times y. In other words, if I do this, okay, that's still correct, but down here, I would need that plus 1 to get back up here.
So my question is this, so why can it be 2x and 2y instead of the 2 on the outside?
Because, oh, and I see that's what you had as your answer. Because then you haven't taken out the greatest common factor. So the 2x plus 2y, you need to take. So basically you want to pull it apart as much as you can.
Okay.
All right, Abel, did you get your question answered?
Yes.
Okay, okay. Anything else, anybody?
No.
All right, we're going to go on then to section 6.2. And what I want to do there is I want to start by reminding you of what happened if you took Math 85 previously, or a beginning algebra course talking about multiplying binomials together. Let's see, I've got x plus 3 times x plus 2. Okay, so I'm going to multiply two binomials together. So we FOIL them. So we take x times x, which is x squared, plus x times 2, which is 2x, plus 3 times x, which is 3x, plus 3 times 2, which is 6. Are you okay with that process? Do you remember doing that? Hopefully that's a yes.
Yes.
Combining like terms, we get x squared plus 5x plus 6. So there's the final answer. Multiplying two polynomials, two binomials together, we get, in this case, a trinomial. All right. Well, now we want to go the other direction. We want to take this trinomial and we want to pull it apart into two binomial factors. So we want to factor this trinomial. Okay. Now, let's look at the mechanics of this and how things work. X times x, so the first times the first, gives us this term, right? Which is here. So that means going backwards, this term would go there. Any questions about that? All right, let's take a look at this term. Where did that come from? It came from 3 times 2. So that means that this number, whatever goes there, times that number, they have to have a product that's equal to 6. Okay. Now, well, that could be what? 2 and 3 or 1 and 6. All right. So just knowing that the product of 6 is not enough. Well, let's take a look at where this came from. That came from these two, which was this number times that number and this number times that number. Okay. So that means that the two numbers that had a product of 6 have a sum of 5. Sorry, my phone is buzzing. Move it away so it doesn't disturb me there, because I'm very disturbed anyway. All right. So I need two numbers whose product is 6 and whose sum is 5. So basically the product is 6 and the sum is 5. Well, let's see. 6 and 1, 3 and 2. Oh, 6 and 1, those have a product of 6, but they would have a sum of 7. So it can't be those. These have a product of 6 and a sum of 5. So there's our two numbers. Okay. So x squared plus 5x plus 6 factors into x plus 3 times x plus 2. Don't panic if you're sitting there going, oh, I didn't really get that. We've got another 45 minutes or so, 40 minutes, whatever, to keep going over this until you do get it. So don't panic. All right, let's take a look at another example, only now we're just going to start with the trinomial. So we know that we're going to split the y's up, one in each factor, okay? Then we're looking for a pair of numbers whose product is 3 and whose sum is 4. So the product is 3 and the sum is 4. Product, sum. Okay. Let's see, what times what is 3? Well, 3 times 1, that's pretty much it. But what is 3 plus 1? It's 4. So there's our two numbers. And there is the factorization. Let's check our work. Let's multiply it back together. Y squared plus y plus 3y plus 3, combining like terms. Y squared plus 4y plus 3, it matches. So there is the correct factoring. Any questions about that problem? Okay, let's take a look at another problem. X squared plus 7x plus 10. We're going to split up the x squared with an x and an x. We need a product, that's 10, and a sum, that's 7. Again, P stands for product and S stands for sum. Two numbers whose product is 10. How about 10 and 1, 5 and 2? But whose sum is 7. Well, this adds up to 11. That adds up to 7. So we've got a plus 5 and a plus 2. Let's check our work. X squared plus 2x plus 5x plus 10, combining like terms, x squared plus 7x plus 10, and it checks. Any questions? Am I going too fast? We're okay? All right. How about this one? N squared minus 7n plus 10. So we're going to split up the n squared n and n. The product is 10, and the sum is negative 7. Well, now, if I use 10 and 1 or 5 and 2, those both have a product of 10, but they both have a positive sum. I need to multiply two numbers together and get a positive product. So that would either have to be a positive times a positive or a negative times a negative to get this. But when I add those two numbers together, I need to get a negative sum. Well, I can't add two positive numbers together and get a negative sum. So what is that telling me? It's telling me my two numbers have to be negative. So negative 10 and negative 1, or negative 5 and negative 2. Those are the ones I would look at. Well, let's see, that's going to give me negative 11. That's going to give me a sum of negative 7. So minus 5 minus 2. Let's check our work. N squared minus 2n minus 5n plus 10. Combine like terms. N squared minus 7n plus 10. And it checks. So there is our answer. Again, any questions about that one? Okay, let's take a look at this one. U squared plus u minus 42. So we'll split up the u squared with a u and a u. The product is negative 42. The sum is what? Well, don't forget there's an implied 1 in front of the u. So the sum is 1. So now I'm looking for a pair of numbers whose product is negative, which means I have to have a positive number and a negative number, or a negative number and a positive number, but whose sum is 1. So that means when I add the positive and the negative, I get a positive 1. Well, how is that going to happen? How am I going to add two numbers, one positive and one negative, so that their sum is 1? Well, wouldn't the positive number have to be 1 bigger than the negative number? So consider this. What times what is 42? Think of your times tables. How about 6 times 7? Oh, if I had a negative 6 and a positive 7, the product would be negative 42, and the sum would be a positive 1. Do you see how that works? Again, any questions there? So checking my work, n squared plus, u squared plus 7u minus 6u minus 42, combine like terms, u squared plus 1u minus 42, and it checks. Okay, let's see here. A squared minus 10a minus 39. So we're going to split it up an a and an a. The product is negative 39, and the sum is negative 10. Well, to get a negative product, I have to have a positive and a negative, or a negative times a positive. But when I add them together, the sum is negative. So that means my negative number has to be bigger. So I'm going to have a big negative, that's supposed to be big, and small positive. Okay, when I multiply them, I get a negative number, but when I add them, I get a negative answer. So let's see, big negative, small positive. How about negative 39 and 1? Or negative 13 and 3? Or I could go 39 and negative 1 and 13 and negative 3. But remember, we determined that the bigger number had to be negative. So let's see, that would give me a sum of negative 38. That would give me a sum of negative 10. So there you go. A squared plus 3a minus 13a minus 39. Combining like terms, a squared minus 10a minus 39. It checks, so there is the answer. Now, something I didn't mention until now, but I want to go back and mention it. In each case, let's see here, this trinomial, along with each other trinomial we've looked at, was in standard form or descending powers of the variable. Y squared, y, no y at all. X squared, x, no x at all. N squared, n, no n at all. U squared, u, no u at all. A squared, a, no a at all. Okay, they were all in descending powers. They also had a leading coefficient of an implied 1. Okay, so let's take a look at another one. X squared minus 3x minus 40. So notice it's in descending powers and it has a leading coefficient on the x squared term of a 1. Those conditions have to be present to do this process. So if that's the case, we can take this, split up the x squared. The product is going to be the constant term, and the sum is going to be the coefficient of the linear or first degree term. Okay. Now, I have a negative product and a negative sum. To have a negative product, I have to have one of each, a positive and a negative. Oops, just a negative, not necessarily a negative 1. Positive and a negative, or a negative and a positive. When I add them together, I get a negative sum, so the negative has to be bigger. So big negative, little positive. Okay, so how about negative 40 and 1? Well, that gives me negative 39 as a sum, but this is even. So what if I cut this in half and double that? That will still give me a product of negative 40. Let's go back here. This had a sum of negative 39. This would have a sum of what, negative 18? Well, I'm still a long ways from negative 3, but I'm getting closer. This negative 20 is even. Let's cut it in half and consequently double that one. I still have a product of negative 40, but now my sum is negative 6. Well, let's keep going. We'll cut this in half and double that one. My product is negative 40. My sum is, a positive 3. But remember, we needed to have a bigger negative. Well, how can I turn that into a negative 3? By using a negative 8 and a positive 5. Do you see how that worked? Any questions there? Okay, so again, x squared plus 5x minus 8x minus 40. Combine like terms, x squared minus 3x minus 40. Okay. Let's see here. Negative x squared plus 9x minus 20. So here we have a trinomial that's in descending powers or standard form, but it doesn't have a leading coefficient of a 1. It has a leading coefficient of a negative 1. So just like we did in the previous section, we're going to factor out that negative 1. Okay. Now we'll take the trinomial that's in the parentheses and factor it. So I'm no longer looking up here. I'm looking at this. Product is 20. Sum is negative 9. Well, it's either got to be a positive times a positive or a negative times a negative. to get a positive product, but I can't add two positives to get a negative. So they've got to both be negative. So negative 20 and negative 1, negative 10 and negative 2, negative 5 and negative 4. Okay, so you could write your answer that way, or you could just write it like that. Okay, with that negative sign out in front there. Any questions about that? Okay, let's take a look at one with two variables. A squared plus 6ab plus 5b squared. Well, this is in standard form in terms of the variable a. It has a squared, a, no a at all. Okay, it isn't in standard form in terms of b, but you know what they say, if it ain't broke, don't fix it. It's going to work for a, so we'll go with a. So we have an a here and an a there, and the product is 5 and the sum is 6. Again, the product is 5, the sum is 6. Okay, how about 5 and 1? But there's something missing. What have I forgotten? What isn't there? Anybody? Nope. Okay. B, I need the b squared. So just like I split up the a squared at the front, I'll split up the b squared at the end. Okay. So a plus 5b, a plus b. That's a squared plus ab plus 5ab plus 5b squared, combine like terms, a squared plus 6ab plus 5b squared, and it works. This is the same as this. I just recopied it to make it a little more legible. The keyword there is little. Okay, now about this one. 3y squared minus 21y plus 18. Well, this is a trinomial, and it is in standard form or descending powers of y. However, it doesn't have a leading coefficient of a 1. It has a leading coefficient of a 3. But if we factor out the greatest common factor, we now have a trinomial inside the parentheses that fits the pattern. It has a leading coefficient of a 1. So the y squared gets split up, y and y. The product is 6. The sum is -7. Notice again, I'm not looking up here now. I'm looking at these numbers to get my 6 and -7. Okay. Well, a product that's positive has to be positive times positive or negative times negative, but the sum can't be negative if there's two positives. So there have to be two negatives. Well, there it is. I didn't even need to try that one, did I? So -6 and -1. Well, let's check our work here. Let's see. 3y minus 18 times y minus 1. 3y squared minus 3y minus 18y plus 18. 3y squared minus 21y plus 18, and it checks. So there is the final answer. Don't stop here. You got to factor it as far as you can. Okay. Let's see. Let's take a look at this one. -m cubed plus m squared plus 56m. Well, this is a trinomial. It's in standard form. It doesn't have a leading coefficient of a 1. Not only that, but there's a greatest common factor of an m. But our leading coefficient is negative, so we're going to factor out a -m. So we'll get m squared minus m minus 56. Okay, let's make sure we've done that correctly. That's minus m cubed plus m squared plus 56m. Okay. So now let's factor this thing further. Product is negative 56. Sum is negative 1. To get a product that's negative, we need a positive and a negative. Oops, I keep wanting to write a 1 there. Positive and a negative, or a negative and a positive. But the sum is negative. So the negative has to be bigger than the positive, but only slightly. Can you think of two numbers who multiplied together give you 56, and those two numbers are really close? How about 8 and 7? Oh, but one of them has to be negative, the bigger one. So negative 8 times 7 is negative 56. Negative 8 plus 7 is negative 1. So there we go. Okay. To check our work, negative m squared plus 8m, all of that times m plus 7, negative m cubed minus 7m squared plus 8m squared plus 56m, combine like terms, negative m cubed plus m squared plus 56m, and it checks. So here is the final answer. Any questions there? All right. Let's say we've got this problem. Y squared plus 100 plus 25y. What's wrong with this problem? Anybody? Nope. Okay. It's not in descending powers, so we need to rearrange it. So now it's ready to go. It has a leading coefficient of a 1. There's no greatest common factor, so we'll split it apart. The product is 100. The sum is 25. Well, the product is positive, so it's got to be a positive times a positive or a negative times a negative. But the sum is positive. We can't add two negatives together and get a positive number, so they've got to both be positive. So how about 101? Well, that has a product of 100, but the sum would be what? 101. That's not 25, is it? Well, let's take the 100 and cut it in half and consequently take the 1 and double it. We still have a product that's 100, but now the sum is 52. Well, let's see. We're getting warmer, but still not there. 50 is even, so I could cut that in half and double the second one, and I'd have a sum that's 29. Well, I can't cut 25 in half, but I could take a 5 out of 25. So if I divide that by 5, I'll have to multiply the 4 by 5, and I get 20, and that gives me a sum of 25. So there it is. There's my two numbers, plus 5 plus 20. Okay. Sometimes you hit it right on, sometimes you go past it and you have to work your way to the middle. Anyway, so there's the answer to that. Let's see here. How about this one? U squared plus 10u plus 15. So this is a trinomial. It's in standard form, descending powers of u. It has a leading coefficient of a 1. There's no greatest common factors, so we need a product that's 15 and a sum that's 10. All right. Since the product is positive, it's either got to be two positives or two negatives. But for the sum to be positive, we couldn't add two negatives. So it's got to be two positive numbers. So 15 and 1, 5 and 3. I think those are the only possibilities. 15 plus 1 is 16. 5 plus 3 is 8. None of them are going to work. That's because this is prime. So the correct answer is to write prime, meaning that we can't factor it. Just like the number 17 is a prime number. It can't be factored. Okay. All right. Other than 1 times 17, but that doesn't really do anything for us. Taking 1 times all of that doesn't really do anything for us. Any questions about that problem? Okay. Let's see here. Now they kind of mix problems together from 6.1 and 6.2. Let's take a look at this problem. 40c squared minus 12c. This is not a trinomial. This is a binomial. And it has a greatest common factor. Let's see. I think it's 4c. That would be 10c minus 3. Yeah, because there's nothing common to both of those other than a 1. And there's 40c squared minus 12c. So there's the answer. Okay. How about this one? Negative r squared plus 14r minus 45. This is a trinomial. It's in standard form. It doesn't have a greatest common factor other than it doesn't have a leading coefficient of a 1. So let's factor out a negative 1. Okay. So now, product of 45 and a sum of negative 14. Well, the product is positive, so it's got to be 2 positive numbers or 2 negative numbers. But if we find the sum of those 2 numbers, if you add 2 positive numbers together, you aren't going to get a negative sum. So it has to be 2 negatives. How about negative 45 and negative 1? Well, that gives me what? A sum of negative 46. Negative 45 isn't even. I can't take a 2 out, but I could take a 3 out. So negative 15 and what? Negative 3. That would still give me a product of negative 45, but it would give me a sum of negative 18. Let's see. I could take another 3 out. This would be a negative 5 and a negative 9, and that would give me a sum. Oh, there you go. So minus 5 and minus 9, and there's the final answer. Let's see. Let's take a look at this one. M squared plus 3m minus 20. Okay, here is a trinomial. It's in standard form. It has a leading coefficient of a 1. So we're going to get that. The product is negative 20 and the sum is 3. To get a product that's negative, we either need a positive times a negative or a negative times a positive. But when we add them together, the sum is positive. So the bigger number has to be positive and the little number has to be negative. So 20 and negative 1. In other words, I wouldn't take negative 20 and 1 and try that because that doesn't fit the pattern of a bigger positive and a smaller negative. Okay. And let's see here. I could cut that in half. Oops, I didn't do that though. So I'd have what? 10 and negative 2. Well, this is what? A sum of 19. This is a sum of 8. Cut it in half and double it, a sum of 1. My number I'm looking for is right in the middle there, between 8 and 1, which means the 2 numbers I'm looking for have to be in the middle between the 10 comma negative 2 and the 5 comma negative 4. So my pair of numbers, one of them has to be between 10 and 5, and the other has to be between negative 2 and negative 4 to get a number that's between the 1 and 8, which is the 3. Well, there's quite a few numbers between 10 and 5, so let's go after the other one. Between negative 2 and negative 4 is a negative 3. Negative 3 times what equals negative 20? Well, it would have to be a fraction, right? So there is no pair of numbers I can find, so this is prime. And there you have it. All righty, that's all I have for today. So I'm going to stop the recording. Give me just a second here.